In this tutorial, we are going to tune our primary gas meter for weather. We tune our meters for weather so we can make our current and our baseline energy usage comparable. By tuning, we effectively remove weather from the equation. To tune our primary gas meter, we're first going to select the primary gas meter item from the tree structure. Next, I'm going to select the Tuning tab. Before we tune our meter, we need to select the number of bills which we would like to include in our tuning period. Generally, you would like a year's worth of bills in your tuning period, so I'm going to enter in 12. Next, we need to select the bill which we would like our tuning period to start at. In this case, I want to start at bill number 2, because I want our tuning period to start in February of 1993 and end in February of 1994. Now let's see if we can find a relationship between energy usage and weather. To do this, I'm going to change the x-axis of our graph to outdoor temperature. We can see from the usage versus temperature graph that as temperature decreases, our natural gas consumption increases. This tells us that the natural gas is being used to heat our building. We can also see from the graph that there are two fairly distinct lines. One horizontal line representing our base load or non-temperature sensitive energy usage, and one slope line representing our temperature sensitive energy usage. The point at which these two lines intersect, which in this case is approximately 67 degrees, is known as our balance point, and this is the point at which our building begins to heat. So for temperatures greater than 67 degrees, our energy usage remains constant. However, for temperatures less than 67 degrees, our energy usage increases as temperature decreases. So let's tune with heating degree days, because as temperature decreases, our energy usage increases. To tune with heating degree days, let's first select the heating degree days box under Tune With. Now let's change the x-axis of our graph to heating degree days. We can see that along with the build data points on our graph, there is also a fit line, which was generated from the regression equation, which is shown at the bottom of the Tuning tab. Now let's change the regression equation by changing the balance point to 67 degrees, and this is the value that we estimated by looking at the usage versus temperature graph. Notice as I change the balance point down to 67 degrees, our regression equation as well as our statistical indicators change. The most important of our statistical indicators is our r-squared value. The r-squared value represents how well our fit line matches our build data, and we want our r-squared value to be as close to 1 as possible. Notice as I bring our balance point down to 67 degrees, our r-squared value increases. At 67 degrees, our r-squared value is 0.982, and all of our statistical indicators have green check marks next to them, indicating that we have a good tuning. Now let's see if we can bring our r-squared value even higher. We already know that for balance points above 67 degrees, our r-squared value will decrease. Now let's see what happens to our r-squared value as we bring our balance point below 67 degrees. At 66 degrees, our r-squared value actually increases to 0.983. At 65 degrees, it remains constant. And with a balance point of 64 degrees, our r-squared value begins to decrease. So for our final tuning, we either want our balance point to be 66 or 65 degrees, because this gives us the highest r-squared value. Let's change our balance point to 65 degrees. With a balance point of 65 degrees, we have the highest r-squared value, and all of our statistical indicators have green check marks next to them, indicating a good tuning. So what we have just done is manually tuned our primary gas meter with heating degree days. We can tune all of our meters manually, or we could have Metrix tune them for us. Using the Autotune feature, we can have Metrix find the regression equation which gives us the best statistical indicators for a given tuning period. Let's auto-tune our primary gas meter. To do this, let's select the Autotune icon under the Tuning tab. A window pops up asking us if we would like to override the user's bill selection or deselection. Select Yes. And we can see that Metrix has come up with the same regression equation as we did manually. Now let's auto-tune our primary electric meter. I'm going to select the primary electric meter item from the tree structure, and under the Tuning tab, we need to enter the number of bills which we would like to include in the tuning period. I'm going to enter in 12 because we want a year's worth of bills within our tuning period. And we are going to start our tuning period at bill number 7, so we have the same months in our tuning period as we did for our primary gas meter. Now let's change the x-axis of our graph to outdoor temperature to see if we can find a relationship between energy usage and weather. As temperature increases, our electrical consumption increases, so we'd expect Metrix to auto-tune our meter with cooling degree days. Now let's change the x-axis of our graph to cooling degree days. We're now going to auto-tune our primary electric meter by clicking on the Autotune button at the bottom of the Tuning tab. A window pops up asking us if we would like to override the user's bill selection or deselection. Click Yes. And we can see that Metrix has auto-tuned our primary electric meter for us. All of the statistical indicators have green check marks next to them, and we have a high R-squared value. All of this points to a good tuning. Now let's see how well our best fit line matches our bills from our tuning period. To do this, I'm going to change the x-axis of our graph to time. And we can see that our best fit line matches our bills very closely. Now let's do a scenario inspection to see how well our baseline compares with our actual usage over time. Let's go to the Scenario Inspection tab. Let's change the number of bills that we would like to include in our scenario inspection to 24, so we can see 2 years worth of billing data. Looking at the usage versus time graph, we can see that there are two lines. The green line represents the baseline energy usage, and the black line represents actual energy usage. We can see that from February of 1993 to February of 1994, there is almost no difference between the baseline and actual energy usage, and this is due to the fact that this was the period used in tuning. As I advance time, we can begin to see a difference between our baseline and our actual energy usage. And this difference between the baseline and actual energy usage is known as our energy savings. This is the energy that we saved by adding the energy conservation measures to our building. In this tutorial, we found a relationship between energy usage and weather within our primary gas meter. We then took this relationship and manually tuned our primary gas meter. We then auto-tuned our primary gas and our primary electric meters. Finally, we did a scenario inspection on our primary electric meter to see how our actual energy usage compares with our baseline.